from the University of Manchester, and this is to talk about the component system that we've been building in Taverna as a way of doing adding semantic annotations and making units of functionality that can be shared and used to build workflows. So a component is very much it's just a block that you can put it in a workflow. The idea being that it is well described. So this is not just in terms of something that is, oh, this is a chunk of workflow, but it's also, it'll have, have documentation with it, semantic annotations that precisely describe what it does. So the idea is that people can actually look at it both with software and as users and actually see what's going on. It's also it has to be one that behaves well, so that people can actually rely on the component being there and actually doing what it promises to do. The component should have someone who actually is going to be curating it, so that these things can be relied on not just for now, but also for the future. And because of that, we actually have we're working on a repository of components. And a component will actually be producing its input, taking its input and producing its output in agreed formats. The component also fails. When the component fails, it actually will fail in a way that is actually predictable, so that the consumers of the component can actually handle the case of failure, or at least recognise what's actually gone wrong, and of course components are producing provenance. These are the key features of them. So as I say, the usefulness of components is that they have this predictable good behaviour, and they conform to an agreement which is going to be specific to the area that the component is working in. So an example of a component might be a gene analyzer. So, though of course there will be many different types of components in this area, one of the purposes of a component is to hide the complexity of actually calling these things, so that the users of the component can just drop it into their workflow and without having to understand the details of calling the tool or service that is being wrapped. And by making the components work together, then it makes it much easier for the users to build more complicated workflows than they would otherwise be able to. So, as I've been mentioning, this agreement, and the idea is that the agreement is a condition of being a member of a family of components. So that different domains will have different agreements, and so astronomy data is very different to biodiversity data. Digital library components do the same tasks as physiology components. Yet we have components working in all of these different areas. So though some of them are currently private. And these agreements are formalized as component profiles. So the idea is that the profile describes precisely what the interface is. It's similar to the idea of an interface in a programming language, except that it's done. We do it with semantic annotations that we capture not just the typed information, but also what the actual functionality is, and what the promises and guarantees of these components are. So we have support in Taverna for components as a prototype plugin for Taverna 2.4, and it will form part of Taverna 2.5 as a built-in key feature, and of both the workbench and also of Taverna server. And though in the case of Taverna server, this will actually require that you publish the components to an accessible repository, because otherwise it won't be actually available. Because your local repository, local on-disk repository, visible from the service. So if we look at the architecture of components, you can see that if you look at the blue parts, you have the component family, of which components are part of, and everything in the component family shares a common profile which the component conform to. There's of each component is a versioned entity, where each of the versions is actually a Taverna workflow. And then we have semantic annotations, which are all defined by an ontology, which you can specify as in the profile. And the other key feature is that we have inheritance between profiles. So we have a common root profile which defines all the annotations for things like who is the author of a component. So using the friend ontology and things like this, but we give full space for the annotations on ports to actually describe the type of the inputs and outputs to be in an application-specific ontology. So if we look at drilling down a little bit into the implementation, every component family is either a pack on my experiment, or it's actually a directory on your local machine, which is useful for when you're developing them. So that components are defined by a workflow in a component family. So the components are versioned by my experiment, and this is actually, and we simulate this for when you're doing local development, and this is actually a very useful way of working, because you also we allow you to actually select which version of a component you use in the workflow, so that if you find that so you can easily upgrade a component, or if you find that in fact there happens to be a bug, you can actually downgrade and go to a previous version. The semantic annotations are actually stored as RDF in part of the workflow definition, and a full description of the semantics of the component, including its workflow structure, are produced by my experiment when you publish the workflow. So if we look at what's inside the workflow, inside the component packs of my experiment, what is essentially what you've got is definitions, descriptions, and documentation. So as you can see, you have the realizing workflow, but you've also got sample data so that people can see how to use the component, and a usage manual. This would be for a full high-quality component. If you could leave some of these pieces out, except for the workflow itself, but this would produce a rather lower value component and much harder for people to use. But we also included in there would be things like what you depend on, which is actually turns out to be really important in many use cases. So to find the next component, you can either do it by exploring through the My Experiment web interface, or you can actually use the Taverna service browser, which the component system plugs into. So as you can see, there's a list of components that have been published by a project. So and then from there you would just drag and drop them into the main workflow development panel. So it's very easy to make use of these components. But it's important that you don't actually just think of components as being like nested workflows. They are nested workflows, but they're more than that. They obey a set of rules. They hide the details of what's inside. The idea is that you can just rely on those components doing what they published information about what they do. I mean, you can drill down inside to check that what they're doing is correct, but you shouldn't normally have to. So when you're creating a component, you do it by you create a workflow which actually which does this thing which you want to have as a component functionality, and then you do it, and then you attach annotations to that workflow. You select what family you want it to be in. This defines what ontology the permitted annotations can come from, and then you can just go and choose the terms from that ontology and attach them to the entities in the workflow. Particularly the overall workflow and the input and output ports. These are the most common things to be annotating. Though sometimes it's also useful to be able to attach annotations to individual services, so that you can record things like what dependencies that particular service actually has. So that you can track things like version numbers and things like that. And then we have extensions to my experiment so that we can do the snapshotting, semantic collation searching to enable components. So if we look at doing some semantic annotation, here we have example where there is this is from a port on a workflow where it states that it handles a JPEG 2000 image, and that it fits the model of characterization, which is defined by the ontology. So when you say that you want to change one of these annotations, what it then does is it pops up a dialog, and you can choose from a drop-down box. And as you can see at the bottom, it then records these as RDF, which is incorporated into the workflow. So this semantic annotation is actually not going to be confined to components, and will in fact form a general feature of future Taverna workflows and workflow arrays. So the effect on workflows is that it allows component developers to focus on just working on the component, and it provides a much easier way for them to just publish what their changes. The component users can much more easily make use of these components, because they can easily find them, they can easily upgrade the ones that they're using, or if necessary, though I hope not, revert to a version which they found works, and we also are working on enabling swapping out of one component for another where they support the same interface, because with the richness of having semantic annotation, we can actually define a nice meaning of when two workflows actually achieve the same thing, which is generally a fairly application-specific concept. And you can also do proxying for components where necessary. From the perspective of the workflow, components are very much black boxes, but they are really easy to use black boxes, and you can make your own. So if we look at the semantics in this is an extracted version of this semantics of a component. You can see that it's rather long, and we've actually cut this down. But there's some of this is semantics that are from the workflow structure, and some of these are semantic annotations that have been explicitly written. And then by using that, we can actually then allow people to use a Sparkle query to find components that they want to use in a workflow, and this is functionality that we're working on leveraging more widely. So you can use a Sparkle query to find something that will actually do the behavior that we want, and then pick and then narrow down to what version which you want to be inserting. In terms of future work, we're looking much more at treating the whole workflow as an RDF model, so as to get better semantic searching over whole workflows as opposed to just the component parts. I'll be looking at improving the searching and looking at improving compound object creation. A major area is working on the creation of workflows from templates, so that people can just easily pop up have a website where they go along and just say, I want a workflow that does this and feeding these things together, and it just allows you to just pick items from one item from this, one item from that, and you'll know that they work together because they're curated. We're also looking very much at a collection of detailed provenance from the components, not just knowing what produced what output, but also tracking things like what's the version number, so that you can say, this workflow from a while ago, I've got to rerun it because it depended on something that had a critical bug. And we're also working to enable third-party component repositories, because we don't actually want to be the sole guardian of all components ever. And I'd like to thank these projects, which are the projects that have been supporting this work. Any questions?
Thank you. I actually have a question. So one of the things I commonly find myself doing is I try to swap out particular component, well, I wouldn't call them components now that you define what components are, particular tools that perform the same function in a workflow. So I want to see which one is better or try different ones out. Is that easier to do with these components?
Yes. One of the things that we're working on is defining a swap group, so that you can say that these things are specifically swappable with each other within some context, because you can have different levels of swappability. Because you can have two cases whereby these tools perform the same function, but you care about whether they use different algorithms or not, because it depends on what level you're studying the area at. But yes, the idea is that you have these multiple levels of similarity.
Fantastic.
Have you talked to Jessica Kissinger's lab in the University of Georgia? She's been doing some interesting stuff using semantically annotated tools to make tool suggestions. If I'm using tool X, we know from semantic annotation that tool Y is also similar. Maybe you could try that. That's the idea.
I don't believe we've talked to her, but we probably should, since we're looking at the same sort of thing.
I can give you a link to a
That would
presentation.
be very valuable, please.